This is the Self-Driving Vehicle Justification and Implementation Project. We are Group 5. My name is Samuel Lowe.
I'm Noah Stetzel.
I'm Garrett O'Keefe.
I'm Quinn Monahan.
And this project was done by students at Iowa State University in the Department of Industrial and Manufacturing Systems Engineering. The problem. At Danfoss in Ames, 3 new assembly lines are being installed, those being H1T, H1B, and M53. They need a new way to transport units from the assembly line to the paint line, and they also need to know the amount of whip space for each line. The objectives for this project is to design optimal transportation routes for all 3 lines in terms of cost, safety, and speed. We will recommend and justify a single transportation system with a target of $220,000 in annual savings and a 40% internal rate of return. The final recommendation has to be flexible to change for a new paint line that's scheduled for implementation in 2023.
The biggest assumptions and constraints are the installation of a new paint line will begin in 2020 and will be finished in 2023, so it needs to be flexible for that. All predicted forecasts of all of the product sales will not change, and that was a big part of looking into the future for our project, and the project will not impact or be impacted by sales. Fork trucks and SDVs are all limited to 3 miles per hour per safety code. The SDV vendor was already selected, and the overall footprint of Danfoss cannot be expanded. The first thing that we did was some observed time studies of both empty and full push carts and unloading and loading of these push carts. And then we also did studies about scanning the unit and placing it onto a paint pallet adapter to go onto the paint line. Additionally, we looked at fork truck loading and unloading times. We then put all of those times that we collected into JUMP to perform an analysis, which we then input into Simio.
So using the inputs from the observed time studies, we made 3 different simulation models in Simio, one for the fork truck system, one for the SDV system, and one for the pushcart system. We weren't able to observe SDVs, so we had to use a rough estimate of their different loading and unloading times. And then to actually see what the system would look like over the next 5 years, we ran experiments using the production estimates for years 2019 to 2023. So from what we found in the model for the pushcart operators was that 2 operators are going to be necessary for every shift after 2019. There's fairly stable worker demand for every shift and every year, and there is never more than 6 units of whip on all the lines. For the fork truck system, we found that 2 operators, again, are going to be necessary for every shift after 2019. Their utilization or demand is fairly constant across all years. But there is potential for the drivers to do other material handling tasks during 2nd and 3rd shift because their utilization is fairly low. We also found so for the SDV system, we found that technically 1 SDV has the capacity for all 3 lines for the next 5 years. However, it's almost at maximum utilization when there's only 1 in the system. So using 2 SDVs is ideal. Because 2 SDVs in the system have a lower utilization, they are able to handle unexpected demand, or if 1 SDV is down, the other SDV can take care of everything.
Okay, so for economic opportunity, this just summarizes our cost comparison. So if you look at full push cart against an SDV, you can see that the SDV's expenses are a lot higher at the start, but you're saving a lot of money every year, around $300,000. So net present value would be $350,000, and the IRR is about 51.34%, which is based on a 5-year IRR. And if you look at it compared with the fork truck system, the fork truck system actually costs a lot more than well, not a lot more, but a decent amount more than the push car system. So the net present value of savings is around $600,000, and the IRR is 87.5. So overall, we saved around $300,000 annually by using SDVs versus push carts, and with a net present value of $345,000 for a 5-year basis, and an IRR of 51.3%. We need to reevaluate the system for a new paint line around 2023. That's the next steps for the company.
And that's our project.